Management Studies IGNOU presents an audiobook on the course Mmpc 015 Research Methodology for Management Decisions for MBA program. Presenting Block 2 Data Collection and Measurement, Unit 7 Sampling and Sampling Designs, Part 1.
Objectives. On successful completion of this unit, you should be able to 1. Explain the advantage of sampling vis-a-vis census operations. 2. Identify the population, sample, sampling unit, and sampling frame. 3. Apply probabilistic consideration to use simple random sampling with or without replacement. 4. Discuss the idea of stratification of a population and to use stratified sampling method to improve precision. 5. Describe the other sampling methods of data collection suitable in relevant cases. Design a suitable sampling scheme, keeping both cost and precision in view. And 6. Explain the use of non-probability sampling despite its theoretical weaknesses. Introduction. The terminology sampling indicates the selection of a part of a group or an aggregate with a view to obtaining information about the whole. This aggregate or the totality of all members is known as population, although they need not be human beings. These select part, which is used to ascertain the characteristics of the population, is called sample. While choosing a sample, the population is assumed to be composed of individual units or members, some of which are included in the sample. The total number of members of the population and the number included in the sample are called population size and sample size, respectively. While the definitions of a population and a sample have been introduced in a formal manner in the previous paragraph, the idea of sampling is not really new. The process of generalizing on the basis of information collected on a part is really a traditional practice. The annual production of a certain crop in a region is computed on the basis of sample. The quality of a product coming out of a production process is ascertained on the basis of a sample. The government and its various agencies conduct surveys from time to time to examine various economic and related issues through samples. With the advancement of management science, more sophisticated applications of sampling in business and industry are available. Sampling methodology can be used by an auditor or an accountant to estimate the value of total inventory in the stores without actually inspecting all the items physically. Opinion polls based on samples is used to forecast the result of a forthcoming election. Advantage of sampling over census. The census or complete enumeration consists in collecting data from each and every unit from the population. The sampling only chooses a part of the unit from the population for the same study. The sampling has a number of advantages as compared to complete enumeration due to a variety of reasons. Less expensive. The first obvious advantage of sampling is that it is less expensive. If we want to study the consumer reaction before launching a new product, it will be much less expensive to carry out a consumer survey based on a sample rather than studying the entire population, which is the potential group of customers. Although, in decennial census, every individual is enumerated, certain aspects of the population are studied on a sample basis with a view to reduce cost. Less time consuming. The smaller size of the sample enables us to collect the data more quickly than to survey all the units of the population, even if we are willing to spend money. This is particularly the case if the decision is time-bound. An accountant may be interested to know the total inventory value quickly to prepare a periodical report like a monthly balance sheet and a profit and loss account. A detailed study on the inventory is likely to take too long to enable him or her to prepare the report in time. If we want to measure the consumer price index in a particular month, we cannot collect data of all the consumer prices even if the expenditure is not a hindrance. The collection of data on all the consumer items and their processing in all probability are going to take more than a month. Thus, when ready, the price index will not serve any meaningful purpose. Greater accuracy. It is possible to achieve greater accuracy by using appropriate sampling techniques than by a complete enumeration of all the unit of the population. Complete enumeration may result in accuracies of the data. Consider an inspector who is visually inspecting the quality of finishing of a certain machinery. After observing a large number of such items, she cannot just distinguish items with defective finish from good ones. Once such inspection fatigue develops, the accuracy of examining the population completely is considerably decreased. On the other hand, if a small number of items is observed, the basic data will be much more accurate. It is of course true that the conclusion about a population characteristic, such as the proportion of defective items from a sample, will also introduce error in the system. However, such errors, known as sampling errors, can be studied, controlled, and probability statements can be made about their magnitude. The accuracy which results due to fatigue of the inspector is known as non-sampling error. It is difficult to recognize the pattern of the non-sampling error, and it is not possible to make any comment about its magnitude, even probabilistically. Destructive enumeration. Sampling is indispensable if the enumeration is destructive. If you are interested in computing the average life of fluorescent temps supplied in a batch, the life of the entire batch cannot be examined to compute the average, since this means that the entire supply will be wasted. Thus, in this case, there is no other alternative than to examine the life of a sample of lamps and draw an inference about the entire batch. Simple random sampling. The representative character of a sample is ensured by allocating some probability to each unit of the population for being included in the sample. The simple random sample assigns equal probability to each unit of the population. The simple random sample can be chosen both with and without replacement. Simple random sampling with replacement. Suppose the population consists of n units and we want to select a sample of size n. In simple random sampling with replacement, we choose an observation from the population in such a manner that every unit of the population has an equal chance of 1 by n to be included in the sample. After the first unit is selected, its value is recorded and it is again placed back in the population. The second unit is drawn exactly in the swipe manner as the first unit. This procedure is continued until nth unit of the sample is selected. Clearly, in this case, each unit of the population has an equal chance of 1 by n to be included in each of the n units of the sample. Simple random sampling without replacement. In this case, when the first unit is chosen, every unit of the population has a chance of 1 by n to be included in the sample. After the first unit is chosen, it is no longer replaced in the population. The second unit is selected from the remaining n-1 members of the population so that each unit has a chance of 1 by n-1 to be included in the sample. The procedure is continued till nth unit of the sample is chosen with probability 1 by n-n plus 1. Sampling frame. A sampling frame is a list of all the units of the population. The preparation of a sampling frame is sometimes a major practical problem. The frame should always be made up to date and be free from errors of omission and duplication of sampling units. A perfect frame identifies each element once and only once. Perfect frames are seldom available in real life. A frame is subject to several types of defect, which may be broadly classified on the following lines. 1. Incomplete frame. When some legitimate sampling units of the population are omitted, the frame is said to be incomplete. If we want to collect information regarding the political opinion of a group of voters on a sample basis, A complete list of voters is necessary to select a sample, but instances are known when such a list is incomplete. 2. Inaccurate frame. When some of the sampling units of the population are listed inaccurately or some units which do not actually exist are included, the frame is said to be inaccurate. If you use the list of ration cards as a frame to select persons, obviously such a frame will be inaccurate as the details about the person such as age are never updated. 3. Inadequate frame. A frame that does not include all units of the population by its structure is an inadequate frame. If you use the list of names included in the telephone directory of a city as the frame for selecting a sample to collect information about a consumer product, obviously it will be an inadequate frame. It will include the names of only those persons who have a telephone, omitting the majority of the residents of the city. 4. Out-of-date frame. A frame is out of date when it has not been updated, although it was accurate, complete, and adequate at the time of preparation. The use of census blocks as a frame to select a sample of households is a fairly accurate frame immediately after the decennial census, but thereafter, its reliability as a frame deteriorates in a rapidly growing or rapidly declining area. Probabilistic aspects of sampling. Simple random sampling is based on the concept of probability. The use of probability in sampling theory makes it a reliable tool to draw inferences or conclusion about the population. Although the types of conclusion or inference can be quite diverse, two types of decision making are quite prevalent in problems of business and government. On various occasions, the management would like to know the percentage or proportion of units in the population with a certain characteristic. An organization selling consumer products may like to know the proportion of potential consumers using a certain type of cosmetic. The government may like to know the percentage of small farmers owning some cultivable land in a rural region. A manufacturer planning to export some product may be interested to ascertain the proportion of defect-free units his system is capable of manufacturing. The performance level of many products in mass production shows statistical variation. This aspect of quantitative analysis has been discussed in Mmpc 005, Block 3. Thus, we would only indicate the results without details. A manufacturer of fluorescent lamps would like to know the average life of these lamps, keeping in mind that there will be variation in life between individual lamps. An investor could be interested to know the prices of a number of stocks, but as the prices vary over the year, he may look for the average price of these stocks over the year. Stratified random sampling. The simple random sampling may not always provide a representative miniature of the population. Certain segments of a population can easily be underrepresented when an unrestricted random sample is chosen. Hence, when considerable heterogeneity is present in the population with regard to subject matter under study, it is often a good idea to divide the population into segments or strata and select a certain number of sampling units from each stratum, thus ensuring representation from all relevant segments. Thus, for designing a suitable marketing strategy for a consumer durable, the population of consumers may be divided into strata by income level, and a certain number of consumers can be selected randomly from each stratum. Other methods of sampling. 1. Cluster sampling. In this method of sampling, a collection or a cluster of sampling units are selected in a random manner. Then, each unit of the cluster is included in the sample. In order to motivate the user of a cluster, we consider a survey where the sampling units are households in a rural area. If simple random sampling is used to select households, they will be located over several villages. On the other hand, a village can be regarded as a cluster of households. We select a few villages randomly and include every household in the selected villages in our sample. Such a sampling procedure will be an illustration of cluster sampling. It has a number of advantages over simple random sampling. A. If the household are chosen using simple random sampling, they are likely to be distributed over several villages. Hence, from an administrative point of view, such a selection will involve more cost, more field supervision, and traveling. On the other hand, if a selected village is completely enumerated, the cost involved will be lower and the supervision exercised will be better. B. If the households in the sample are distributed over several villages, then a frame containing the list of households of each of these villages is necessary for proper identification and the selection of the household in the sample. On the other hand, if every household in a selected village is included in the sample, no sampling frame listing the households in a village is necessary. C. If the type of question is of intimate nature, an isolated household selected in a village is unlikely to cooperate with the investigators. On the other hand, if every household in a village is visited, a particular household, after observing that his or her neighbors are also being interviewed, are likely to offer greater cooperation, and as such the quality of the basic data will be more reliable. In the example presented in this section, clusters have been formed based on geographic subdivisions. A village is a natural geographic cluster of households. A cluster sample with clusters based on geographic subdivisions is known as an area sample, and the procedure is known as area sampling. A cluster sample need not be always formed on geographic consideration. Suppose we want to estimate the proportion of defective machine parts in the inventory. If there are 20,000 items stored in 400 cases of 50 each, then those 400 cases can be considered as clusters. A cluster sample of 10 cases may be randomly selected, resulting in a sample of 500 items. For a given sample size, the variance of an estimator increases, or equivalently, the estimator becomes less precise with a larger cluster size. On the other hand, the cost decreases with the larger cluster size. We may balance the two conflicting aspects of the problems by finding out the optimum cluster size, which minimizes the variance of the estimator for a fixed cost or minimize the cost for a given level of precision. 2. Systematic sampling. The main advantage of systematic sampling is its simplicity of selection, operational convenience, and even spread of the sample over the population. The investigators using this sampling method need not be familiar with the use of random sampling numbers. It has been found very useful in forest surveys for estimating the volume of timber or in fisheries for estimating the total catch of fish. The method can be used even when no formal list of the units of the population is available. As for illustration, a 5% sample of the household in a locality can be selected by selecting every 20th household after all the households are ordered in a systematic manner. Although a systematic sample is not a random sample in the strict sense of the term, its performance is quite comparable to a random sample. However, if there is a hidden periodicity in the population, systematic sampling will prove to be an inefficient method of sampling. As for illustration, if every 25th unit of a production process is defective, a 4% systematic sample will select all defective or all non-defective items depending upon the starting point. Such an orientation is, however, very rare. 3. Multi-stage sampling. This procedure is used for large-scale inquiry covering a large geographical area such as state. As for illustration, a bank may like to gather information regarding the quality of customer service it is offering in a state. A random sample of districts is selected from the list of districts. From each of the selected districts, a number of branches are randomly selected. From each of the selected branches, a number of depositors, which is the ultimate sample sampling unit, is selected randomly for collecting information. The districts are called first stage units, the branches are known as the second stage units, and the depositors are regarded as the third stage unit. This is an illustration of three-stage sampling, the third stage units being the ultimate sampling units. The multi-stage sampling procedure has the advantage that the frame of second stage units is necessary only for the selected first stage units. Likewise, the frame of the third stage unit is necessary only for the selected second stage unit. The procedure is quite flexible and it permits the use of different selection procedures in different stages. It may also be mentioned that multi-stage sampling is the only sampling procedure available in a number of practical situations, such as collecting information about consumers in a large geographical region. This is because no satisfactory sampling frame is available for the ultimate stage units, namely, consumers, and the cost of preparing such a frame is prohibitive. Sampling design. A sampling design is a definite plan for obtaining a sample from a given population. It refers to the technique or the procedure the business researchers would adopt to select units for the sample. It will also indicate the number of units to be included in the sample, also known as sample size. Sampling design is determined before data are collected. While developing a sampling design, the management must pay attention to the following points. 1. Type of population. The first step in developing any sampling design is to clearly define the aggregate of sampling units, namely the population. Sometimes the structure of the population is quite unambiguous, such as the population of a city or the number of workers in a factory. However, there may be occasions where the composition of the population is not so simple. For example, in the context of advertising, a company may like to collect information about the number of television viewers watching the advertisement. 2. Sampling unit. The sampling unit must be identified before the selection of a sample. A sampling unit may be a natural geographical unit such as a state, a district, a village, or a constructed unit such as a house or a flat. It may be a social entity such as a family or a school. It may also be an individual. The management should be able to select the appropriate unit so that its objective is achieved. 3. Type of sample. You have observed in the previous subsections that starting from a simple random sampling, the business researcher has a wide choice of sampling procedures. Each procedure has its suitability for the relevant occasion. The type of frame necessary also depends upon the sampling procedure being used. As for illustration, the use of simple random sampling will require a comprehensive list of the sampling units. But a two-stage sampling will require the list of all first-stage units and the list of all second-stage units in the selected first-stage units only. 4. Size of the sample. There are two basic requirements for the sampling procedure to fulfill. A sample must be representative and it must be adequate. When it is representative, a sample will be a relatively small piece of the population that mirrors the various patterns and subclasses of this population. A sample is adequate if it provides an estimator with sufficiently high precision. It should be remembered in this context that the higher is the precision, the larger is the sample size, and the more is the cost. Non-probability sampling methods. Non-probability sampling is a sampling procedure that does not provide any basis for estimating the probability that each item in the population possesses to be included in the sample. In such a case, the sampling error is not measurable and the error in the estimator tends to increase sharply because the representativeness of the sample member is questionable. Nevertheless, non-probability samples are useful in certain situations. This is the case when representativeness is not particularly the primary issue. In pre-testing a questionnaire, we are interested to ascertain its suitability for the problem under consideration. Non-probability sampling methods can be used to contact respondents in this case, as the primary aim is to probe for the possible range of answers. In general, there are three types of non-probability sampling that may under appropriate conditions be useful in business and government. These are 1. Convenience sampling. Under convenience sampling, as the name implies, the samples are selected at the convenience of the researcher or investigator. Here, we have no way of determining the representativeness of the sample. This results into biased estimates. Therefore, it is not possible to make an estimate of sampling error as the difference between the sample estimate and population parameter is unknown both in terms of magnitude and direction. It is therefore suggested that convenience sampling should not be used in both descriptive and causal studies as it is not possible to make any definitive statements about the results from such a sample. This method may be quite useful in exploratory designs as a basis for generating hypotheses. The method is also useful in testing questionnaires, etc. at the pre-test phase of the study. Convenience sampling is extensively used in marketing studies and otherwise. This would be clear from the following examples. A. Suppose a marketing research study aims at estimating the proportion of pan betel leaf shops in Delhi which store a particular drink, say Maaza. It is decided to take a sample of size 100. What investigator does is to visit 100 pawn shops near his place of residence as it is very convenient to him and observe whether a pawn shop stores Maaza or not. This is definitely not a representative sample as most pawn shops in Delhi had no chance of being selected. It is only those pawn shops which were near the residence of the investigator had a chance of being selected. B. The other example where convenience sampling is often used is in test marketing. There might be some cities whose demographic makeups are approximately the same as national average. While conducting marketing tests for new products, the researcher may take samples of the consumer from such cities and obtain consumer evaluations about these products as these are supposed to represent national tastes. C. A ball pen manufacturing company is interested in knowing the opinions about the ball pen. It is presently manufacturing with a view to modify it to suit customer needs. The job is given to a marketing researcher who visits a college near his or her place of residence and asks a few students their opinion about the ball pen in question. D. As another example, a researcher might visit a few shops to observe what brand of vegetable oil people are buying so as to make inference about the share of a particular brand he or she is interested in. 2. Judgment sampling. Judgment sampling is also called purposive sampling. Under this sampling procedure, a researcher deliberately or purposively draws a sample from the population which he or she thinks is a representative of the population. Needless to mention, all members of the population are not given chance to be selected in the sample. The personal bias of the investigator has a great chance of entering the sample, and if the investigator chooses a sample to give results which favors his or her viewpoint, the entire study may be vitiated. However, if personal biases are avoided, then the relevant experience and the acquaintance of the investigator with the population may help to choose a relatively representative sample from the population. It is not possible to make an estimate of sampling error as we cannot determine how precise our sample estimates are. Judgment sampling is used in a number of cases, some of which are mentioned as A. Suppose we have a panel of experts to decide about the launching of a new product in the next year. If for some reason or the other, a member drops out from the panel, the chairman of the panel may suggest the name of another person whom he or she thinks has the same expertise and experience to be a manager of the said panel. This new member was chosen deliberately, a case of judgment sampling. B. The method could be used in a study involving the performance of salesmen. The salesmen could be grouped into top grade and low grade performer according to certain specified qualities. Having done so, the sales manager may indicate who in his or her opinion would fall into which category. Needless to mention, this is a biased method. However, in the absence of any objective data, one might have to resort to this type of sampling. 3. Quota sampling. This is a very commonly used sampling method in marketing research studies. Here the sample is selected on the basis of certain basic parameters such as gender, age, income, and occupation that describes the nature of a population so as to make it representative of the population. The investigators or field workers are instructed to choose a sample that conforms to these parameters. The field workers are assigned quotas of numbers of units satisfying the required characteristics on which data should be collected. However, before collecting data on these units, the investigators are supposed to verify that the units qualify these characteristics. Suppose we are conducting a survey to study the buying behavior of a product, and it is believed that the buying behavior is greatly influenced by the income level of the consumers. We assume that it is possible to divide our population into 3 income strata, such as high income, middle income, and low income group. Further, it is known that 20% of the population is in high income group, 35% in the middle income group, and 45% in the low income group. Suppose it is decided to select a sample of size 200 from the population. Therefore, samples of size 40, 70, and 90 should come from high income, middle income, and low income groups respectively. Now the various field workers are assigned quotas to select a sample from each group in such a way that a total sample of 200 is selected in the same proportion as mentioned above. For example, the first field worker may be assigned a quota of 10 consumer from the high income group, 25 from the middle income, and 40 from the low income group. Similarly, The second field worker may be given a different quota, and so on, such that a total sample of 200 is obtained in the same proportion as discussed earlier. At the outset, the quota sampling procedure might look similar to stratified sampling. However, there is a difference between the two. Under stratified sampling, the field worker selects a random sample from each cell of the population, whereas under quota sampling, the selection of the sample is not random. It is left to judgment of the field worker. The quota sampling method has some weaknesses. These are listed. 1. It is usually difficult to obtain an accurate and up-to-date proportion of respondents assigned to each cell. 2. As the number of parameters associated with the objectives of the study becomes large, the total number of cells increases. This makes the task of field staff difficult, as it may not be easy to get the desired respondent. 3. It is very important that all of the proper parameters related to the study in question must be incorporated while taking a sample. The results of the study could be misleading if any relevant parameter is omitted for one reason or the other. 4. The field workers might like to visit those areas where the chances of the availability of a respondent satisfying certain desired parameters are very high. Further, the field workers might avoid certain respondents who look unfriendly and live in houses that may not be of good appearance. These factors are likely to make the findings of the study less reliable. The quota sampling method has some advantages too. The method has a lower cost and field workers have a free hand to select respondents for each cell to fill their quota. The samples, if selected with care, would result in more definitive findings. Summary. A sample is a part of a group or aggregate selected with a view to obtaining information about the whole group, also known as the population. The population is composed of a number of units. The total number of units in the population and in the sample are known as the population size and the sample size, respectively. The technique of sampling has been used in traditional problems such as estimating the yield of a crop or examining the quality of an outgoing product. In addition to these traditional spheres, sampling has been applied successfully in management problems such as estimation of inventory by sampling, or in socio-economic problems such as ascertaining the trend of a political process through opinion polls. As compared to the census or complete enumeration, sampling is less expensive, less time-consuming, and more accurate. Further, sampling is the only method for collecting information when the measurement of the sampling unit is destructive in nature. A probabilistic sampling attaches some probability to each unit of the population to be included in the sample, and in this sense, it is a representative sample of the population. A simple random sample attaches equal probability to each unit of the population to be selected in the sample. Operationally, the selection of a random sample is based on a sampling frame containing a list of all the units of population and a table of random sampling numbers. When the population is heterogeneous, we divide the units into several groups, each known as a stratum. The strata are so selected that each stratum is as homogeneous as possible, while the compositions of two different strata are as heterogeneous as possible. The sampling units are selected from each stratum using simple random sampling. This procedure is known as stratified sampling, which improves the precision of the estimator. Another sampling procedure known as clustered sampling is frequently used in consumer surveys in rural areas where a number of sampling units are grouped together as clusters. A number of clusters are selected randomly and the units of each cluster are completely enumerated. A cluster sample incurs less expenditure and provides more reliable data. Other sampling methods used in business research are systematic sampling and multi-stage sampling. A sampling design is a suitable scheme for obtaining a sample from a given population. It also indicates the size of the sample to be used, keeping the cost and precision in view. Non-probabilistic sampling such as convenience sampling, judgment sampling, and quota sampling are sometimes used, although the representativeness of such a sample cannot be ensured.
You were listening to the audiobook by the School of Management Studies IGNOU for MBA program. Course code Mmpc 015, Research Methodology for Management Decisions. Course Coordinator Dr. Venkataya Chittipaka, Associate Professor from School of Management Studies, IGNOU. Voiceover by Renuka. Edited by Savita. Program assisted by Tarannum Jahan and Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.